to Math Unique Plus video. Today's matter of discussion is Rolle's theorem of calculus part 34. What is Rolle's theorem? If fx be a function of x, if it satisfies the three conditions: 1. Continuous in closed interval AB, and if dash x exists in open interval AB. 3. fa equal to fb, then there exists at least one value x equal to c within the interval AB such that f dash c equal to 0. This is Rolle's theorem. Okay. So from 1 fx, Rolle's theorem is applicable to the function or not? It is to be tested. 1i. Fx is given 1 plus x minus 3 whole to the power 2/3. 2x lies between 2 and 4. Then f dash x 0 2/3 x minus 3 whole to the power 2/3 minus 1 minus 1/3. That is 2/3 1 by x minus 3 whole to the 1/3. 3x equal to 3 lies between 2 less than 4. Now f dash 3 does not exist. If you 3, 1 by 0 undefined. So this does not exist. So this function does not satisfy the Rolle's theorem. Okay? So fx does not satisfy Rolle's theorem. Okay? And this is complete. Then number 2. Then number 2, 1, 2, fx equal to 2x, x less than equal to 1, and equal to 4 minus 2x, x greater than 1. Now we have to test the left hand derivative at 1, f dash 1, L f dash 1, that is x tends to 1 minus fx minus f1 by x minus 1. Limit x tends to 1 minus means less than 1. Why less than this? 2 into x minus f1 equal to 1. That is 2 into 1 by x minus 1. That is limit x tends to 2. 2 common into x minus 1 by x minus 1. This is cancelling 2. And r f dash 1, the limit x tends to 2 plus of fx minus f1 upon x minus 1. X greater than 2 means get 1 greater than 4 minus 2 into x minus f1. What is f1 equal to 1? 2 into 1 upon x minus 1. Limit x tends to 1, 4 minus 2, 2 minus 2x. That is 2 into 1 minus x on minus 1 minus x, cancelling minus 2. So L f dash 1 not equal to R f dash 1, and so f dash 1 does not exist. So Rolle's theorem is not applicable to the function. So fx does not satisfy Rolle's theorem. This one is totally completed. Then number 2, fx equal to x cube minus 2x, x less than equal to root 2. If fx satisfies Rolle's theorem, find the value of c within this. Then f dash x 3x square minus 2. So f dash x exists. Therefore fx is continuous in root 2. There is a theorem, if a function is finitely divisible at a point, it is continuous at that point. So it is continuous. Therefore, if 0 equal to 0 and if root 2 equal to root 2 cube minus 2 root 2, that is 0. So there must be some point c equal to 0 such that it is c equal to 0. What is that plus c? 3c square minus 2 equal to 0, c is equal to 2 by 3 and c equal to plus minus root 2 by root 3. C equal to plus root 2 by root 3 lies between 0 to root 2. Hence, the value of c is, so therefore c equal to plus root 2 by root 3. Okay? So 2 complete. Then 3. 2a, let then show that the equation this has at least one real root between 0 and 1. Let fx equal to a into x cube by 3, a into x cube by 2, b into x square by 2 plus cx. Therefore, f dash x equal to ax square plus bx plus c. And therefore, f dash 0, this equal to 0. F dash, what? 2a plus 3b. This is the function. And 2a plus 3b, 2a plus 3b. F, what is f0? F0. F0 means 0, 0 and 0. F0 equal to 0. And f dash, to a equation x should be at least one real root between c. Now f1, what is f1? Between 0 and 1, so f0 and f1, what is f1? A by 3, b by 2 plus c, and it means, and this equal to 6a plus 3b plus 6c by 6, and this is equal to the as per given this. So f0 equal to 0 equal to f1, and the function exists. So by Rolle's theorem, there exists at least one value 0, c equal to 0, such that f dash c equal to 0. It means there exists at least one real root between 0 and 1. Okay, so 3 complete, then 4. Next, number 4. Show that the Rolle's theorem is not applicable to the function this fx equal to of x minus 1. That is fx equal to x minus 1 when x greater than equal to 1, equal to 1 minus x less than 1. L f dash 1. The limit extends to 1 minus fx minus f1 by x minus 1. Limit extends to 1 minus less than 1. That is 1 minus x. And what is f equal to 1? 1 minus 1 by x minus 1. This cancels out. And this is equal to minus 1. R f dash 1 means limit extends to 1 plus fx minus f1 by x minus 1. This limit extends to 1. What is fx? Greater than 1 fx. That is x minus 1. Minus f1. That is 1 minus 1 by x minus 1. This cancels out. This equal to plus 1. So L f dash 1 not equal to R f dash 1. So is violating the one of the conditions that the function is not. So f dash 1 does not exist. Does not exist. So Rolle's theorem is not applicable. Not applicable. Okay. So the problems are not so hard. It's to be practice. Practice more. Okay. Thank you.